research is on enhancing groundwater and management in the Central Valley.
Now, for the research gap in the California Central Valley, there's a need for cost-effective and easy-to-use tools that can gather real-time data and make accurate predictions to improve groundwater management. Our proposal aims to fill this gap by combining the best existing tools, focusing on cost-effectiveness, and delivering better results for groundwater allocation in the region. That led us to the research question, which is what cost-effective tools can be recommended to help local water management agencies monitor and allocate surface and groundwater resources?
We have two methods. First, we reached out to Central Valley Water Management to see what was being used to maintain groundwater supply. Then we researched any tools, programs, and applications. So Fresno County did respond that they use the flow model called ModFlow FMP. USGS uses the same program. The California Department of Water Resources uses GRACE data and AEM surveys.
One of the methods included in this proposal is the Airborne Electromagnetic Survey. The AEM is a geophysical method that maps subsurface properties by measuring how the ground responds to electromagnetic fields. This method is highly cost-effective compared to drilling, and it provides extensive data across large areas without the need for multiple wells. On the other hand, the LiDAR technologies offers high-precision measurements of piezometric levels in wells, which are crucial for understanding aquifer storage and managing groundwater resources. With vertical resolution up to 5 centimeters, LiDAR reduces the need for manual leveling and allows for a better monitoring of large and hard-to-reach areas.
The GRACE, or Gravity Recovery and Climate Experiment, and its improved twin follow-on are two satellites that calculate Earth's gravity field changes. A 2022 study using GRACE's data showed that groundwater is being used more and replenished less with each California drought.
So next up we have ModFlow. ModFlow is a modular groundwater flow model, a 3D finite difference model developed by the USGS focused on the ability to predict groundwater flow. The two diagrams depict how ModFlow uses various inputs and outputs to predict the change in aquifer storage.
Another platform we looked into was OpenET, or evapotranspiration, which is a free online platform that combines data from 6 satellites that's made to track the invisible movement of water. This data can be used by water managers to calculate how much water is needed to replace the water lost.
So what are we using now? For satellite imagery, numerous agencies are utilizing GRACE to obtain gravity field data, and for prediction models, they're using ModFlow as we previously discussed. So where do we find the AEM data? AEM data can be found on the California Department of Water Resources website. Locations and survey areas are listed in the various documents.
For AEM surveys, there are several survey lines near Fresno with valuable data. While more data is needed for a reliable 3D aquifer module, this existing information is still key for preliminary analysis and planning.
LiDAR data can be found on the USGS website by selecting an area and looking through the link selections to review the data. So where do you find ModFlow data? ModFlow is a prediction model that requires various inputs such as groundwater levels and hydrological conductivity. This generates changes in the storage based on the input parameters. Some of these parameters can be found on the USGS website, as seen here, or on the California Department of Water Resources board page.
Where to find GRACE? GRACE can be found for free on NASA's website. It can compare time periods of groundwater levels and create animations. Where to find OpenET? OpenET is also a free and online resource, and it can measure water consumption in selected areas.
Here's a preliminary cost breakdown chart that compares these tools, summarizing the AEM and LiDAR are more cost-effective for covering large areas and providing continuous data, while traditional drilling is more expensive and time-consuming for high-resolution mapping.
In summary, our recommendations for local agencies are to use GRACE and OpenET, then to use ModFlow for prediction changes in the aquifer, as all of the resources are the most cost-effective. Thank you.